Tension is what you get when you exert a force on an object, but that object does not move. We've said before the equation for force is simply your mass times your acceleration. And for the vast majority of MCAT problems, that will be enough. But what happens when you exert a force on something and that force isn't sufficient to make it move? An example would be a weightlifter who tries to lift something that is simply too heavy. The weightlifter exerts a force through his muscles on the barbell, but he can't lift it. It's simply too heavy. There's a force being exerted and there's energy being spent, and that is being translated into tension in his muscles. So you could say that when you exert a force, you really have two options. You could either move the object, and that will result in acceleration, or you could not move the object, and that's going to result in tension. Oftentimes you get a combination of both, a little bit of acceleration and a little bit of tension. To illustrate the relationship between tension and acceleration, let's envision a scenario where I go to the park and run through the park pulling a string behind me. In the beginning, there's nothing grabbing onto the string, so no tension. If I exert a force of 100 newtons, 100% of that force will be dedicated to acceleration. Then what happens if someone comes along and begins to pull on the string? So now, as I pull on my string with a force of 100 newtons, there's someone else on the other side also exerting a force. And let's say this person exerts a force of 50 newtons. What's the tension on my string? The simple definition of tension is the weaker force in one direction. So in this case, I'm exerting a force of 100 newtons to the left. My friend is exerting 50 newtons to the right. He is taking 50 newtons away from the force that I was using to accelerate. So in this case, my tension is equal to 50 newtons. I still have 50 newtons left over, and that's going to be used towards acceleration. Even though my friend is trying to slow me down, both of us will end up moving to the right, although a little bit slower than before. Now let's say another buddy shows up, and he too begins to pull on my string. And this red friend, he's exerting a force of 100 newtons. So my total force going to the right is the 50 plus 100, or 150 newtons going to the right. Now what's my tension? Again, it's just a weaker force going in one direction. So in this case, it's me. It's my 100 newtons. And now instead of moving to the left, we'll start to move to the right. Out of the 150 newtons that my friends are exerting, 100 of that is being dedicated towards tension, and only 50 newtons remain for acceleration. Let's look at a sample problem. So here's a case where we have a 20 kilogram box being slowed down by a rope tied to a pulley. The force pulling the box down is simply our mass times our gravity, or in this case 20 times 10, which is 200 newtons. So we have a force of 200 newtons pulling the object down. We also have 100 newtons exerting an upward force or slowing the object down. Again, the tension in the rope is simply the weaker force in one direction, or 100 newtons. But let's take this problem a step further. What is the resulting acceleration in the box? Well, the equation we could use is simply our force is equal to our mass times our acceleration. But this force isn't referring to our initial force. It's actually referring to what we call our net force, which is our initial force minus the force we lose from tension. So we start off with a force of 200 newtons. Then we lose 100 newtons from tension. Our net force is 100 newtons. Now we could write the equation that our net force, which is 100, is equal to our mass, which is 20, times our acceleration. Do some math, our acceleration is 5. So normally when an object falls, your acceleration is 10 due to gravity. In this case, the pulley and rope are providing enough friction to slow our acceleration down to 5.